Section 5.2, Polynomials, Linear Factors, and Zeros. Today, students will be able to factor polynomials and write polynomials from the given zeros. The first thing we are going to look at is how we factor polynomials, and this is going to be based on all previous knowledge. So in example 1, we are given x cubed minus x squared minus 12x. So you may be thinking, well, I've never seen x cubed before, but you do still know how to factor this. So in all of these, you want to ask yourself, what does x cubed, x squared, and 12x all have in common? And the greatest common factor between those is an x. So if you factor out an x from x cubed, it leaves you with x squared. If you factor out an x from x squared, it leaves you with minus x. And if you factor out an x from 12x, it leaves you with just minus 12. Then you are going to want to check inside the parentheses to see if you can factor that more. So is there two numbers that multiply to negative 12 that add to negative 1? Yes, and that's negative 4 and positive 3. And then all what you're going to do is bring down the x out in front. Press pause, and I want you to try factoring 2x cubed minus 4x squared minus 30, and I left off the x. So what does 2x cubed minus 4x squared and negative 30x all have in common? They all have a 2 and an x in common. So if you factor out a 2x, that leaves you with x squared minus 2x minus 15. Okay, so now we're going to check inside the parentheses. Is there a number that, or numbers that multiply to negative 15 that add to negative 2? And yes, there is. It's going to be negative 5 and positive 3. And then all what you're going to do is bring down the 2x out in front. In example 3, we are given a polynomial function that has already been factored. And from that, I want you to find the zeros, and then we're going to draw the sketch of this polynomial. So to be able to find the zeros of a polynomial function, we need to use the zero product property. So I need to replace the y with a 0, and then we are going to use the zero product property to find each individual zero. So the first one, x equals 0, that's already solved for. Then x minus 3 equals 0, and x plus 5 equals 0. So to move negative 3 to the other side, we are going to add it. So we get x equals positive 3. To move positive 5 to the other side, we're going to subtract it. So you get x equals negative 5. So zeros are points that lie on the graph, so we need to write this as the point 0, 0, the point 3, 0, and the point negative 5, 0. Okay, now we are going to want to find the y-intercept just to give us something else, another point to graph. So remember, to find the y-intercept of any function, you're just going to plug in 0 for x. So we have 0 times 0 minus 3 times 0 plus 5, and since we're multiplying by that 0 in the front, the y-intercept is the point 0, 0. Now we are also going to write down the end behavior because we want to be able to determine what the ends of the graph look like. So let's find out whether it's even or it's odd. So 1x, 2 x's, 3 x's. So that makes it odd, and since all of these are positive x's, it's going to be odd positive. So as x goes to negative infinity, f of x goes to, and it also goes to negative infinity, and then as x goes to positive infinity, f of x goes to positive infinity. Remember, the end behavior is from section 5.1 that we talked about. Okay, so I went to a different screen because I was running out of room, so now we're just going to use all of that information. We're going to put it on a graph, okay? So we're going to graph our zeros. So we're going to graph the point 0, 0, and then the point 3, 0, and then the point negative 5, 0. Okay, so there are my 3 zeros, and then the end behavior as x goes to negative infinity, the end is going towards negative infinity, and as x goes to positive infinity, f of x goes to positive infinity. And now I just start on the left-hand side, and I have to go through all of my zeros, and I have to connect back up with my end behavior. Now, we don't know how high and how low we go on those minimums and maximums. We're going to learn about that in part 2. So remember, it's just a sketch. This is also my 0, but it's also my y-intercept. So right now you just don't have a lot of specifics about it. It's just a rough sketch of what your polynomial should look like. So press pause and try example 4 on your own. I want you to find the zeros of the polynomial y equals x plus 3 times x minus 2, and I want you to draw a rough sketch of the graph. So to be able to find the zeros, I need to do my zero product property, so I need to replace y with 0. And then you set each individual factor equal to 0. So I have x plus 3 equals 0. I have x minus 2. Sorry, I wrote the wrong thing right here. X minus 2 equals 0. To move positive 3 to the other side, we subtract it and we get negative 3. To move negative 2 to the other side, we add it and we get positive 2. Again, remember they're points on the graph, so the 0 is at negative 3, 0, and positive 2, 0. Okay, now let's go ahead and let's find the y-intercept, just in case it can give us another point to give us a more detailed graph. So to find the y-intercept, we plug in 0 for x. So 0 plus 3 times 0 minus 2, so that gives me positive 3 times negative 2, which gives me negative 6. So my y-intercept is at the point 0, negative 6. Alright, now let's add the end behavior. So we need to determine what degree it is. So there's 1 x's, 2 x's. 2 x's is even. And then, since there's no negative sign out in front or negative number out in front, we know that it's even and it's positive. So the end behavior for even positive, as x goes to negative infinity, f of x goes to positive infinity. And as x goes to positive infinity, f of x goes to positive infinity, so both ends are pointing up. Okay, now let's begin to draw the sketch of the graph based on that information that we have. So we're going to start by putting the zeros on the graph. So our first 0 is 2, 0, and then negative 3, 0. And then we have a y-intercept of negative 6. 2, 3, 4, 5, 6. And then my end behavior is up and up. And you're just going to make a rough sketch. So you're just going to come down, you're going to go back through and back up. Okay, so we don't know if the y-intercept 0, negative 6 is the lowest point, but we just know that our parabola is going to go through that point somehow. So everybody's graph might look a little different, but just as long as your end behavior, your zeros, and your y-intercept match, that's all we can go by right now. The factor theorem says x minus a is a factor of a polynomial if and only if a is a 0. In example 5, we want to write a quadratic polynomial that has zeros at 3 and negative 3. So we're basically going from the answers and we're going to go back to the equation that's given to us. So if it says that 3 and negative 3 are a 0, that means x equals 3 and x equals negative 3. So to bring those back, remember we're working backwards. To move the 3 to the other side, we would have to subtract it. So I have x minus 3 equals 0. To move positive 3 to the other side, I'd have to add it. So that gives me x plus 3 equals 0. So now again, working backwards, the zero product property allows me to set those equal to 0 separately. And now we are going to FOIL to put it back into a polynomial. So x times x gives me x squared, x times 3 gives me 3x, negative 3 times x gives me negative 3x, and negative 3 times 3 gives me minus 9. Okay, combine like terms. Positive 3 and negative 3 cancel each other out, so we're left with x squared minus 9. And for it to be a polynomial, it has to be y equals, and y equals x squared minus 9 gives you zeros at 3 and negative 3. Press pause, and I want you guys to practice writing a cubic polynomial that has zeros at 2, 3, and negative 4. So if it's telling you that there's a 0 at 2, that means x equals 2. If there's a 0 at 3, it means x equals 3. And if there's a 0 at negative 4, it means x equals negative 4. To move positive 2 to the other side, we have to subtract it, so we get x minus 2 equals 0. To move positive 3 to the other side, we have to subtract it, so we get x minus 3 equals 0. And to move negative 4 to the other side, we have to add it, so we get x plus 4 equals 0. So now, since they all equal 0, remember we're working backwards, so that gives me 0 equals x minus 2 times x minus 3 times x plus 4. Remember, the zero product property allows you to separate them. So now, since you have 3 things in parentheses, you're going to have to start with the first 2 and FOIL them and bring down 1 for later on. So we're going to start with x times x, and that leaves me with x squared. X times minus 3 leaves me with minus 3x. Negative 2 times x leaves me with minus 2x. And negative 2 times negative 3 leaves me with positive 6. So you want to combine like terms before you keep going. So that leaves me with x squared minus 5x plus 6. And then you want to bring down the x plus 4 because we still haven't multiplied by my x plus 4 yet. So x squared times x leaves me with x cubed. X squared times 4 leaves me with 4x squared. Move on to the next one. Negative 5 times x leaves me with negative 5x squared. And negative 5x times 4 leaves me with minus 20x. Last, 6 times x leaves me with positive 6x. And 6 times 4 leaves me with 24. Last thing you need to do is combine like terms. So there's no other x cubed, so I bring down my x cubed. 4x squared minus 5x squared leaves me with negative x squared. Negative 20x plus 6x leaves me with minus 14x. Bring down the 24, and to make it a polynomial, you have to write y equals in the front of it. So the polynomial y equals x cubed minus x squared minus 14x plus 24 has zeros at 2, 3, and negative 4.